This video will explain how you can identify and acquire publicly available open databases from the internet. Now, we probably need to take a moment and talk about what that really means. There are many news reports almost every day about open databases being exposed to the public. And you may have heard about how security researchers find these open databases, report them to the media, and kind of make a big stink about it when it probably is just public data anyway. Now, I don't want to get into the debate of ethics within this video. I will tell you that we are not going to break any laws. We're only going to deal with publicly available information. But a lot of the data that you might find publicly available and open is not meant to be publicly available. It's probably a mistake made by a company with their database, and you are not intended to get a hold of that data. Now, that being said, there's some ethics considerations here, just simply because some of the data that you might find online through these methods you are not supposed to see. So please evaluate your own policies and procedures. If you work for a government or a private agency, find out if your policies allow you to peer into publicly available open databases, even if they were not meant to be publicly open. And I hope I haven't confused you too much at this point. Let's go ahead and jump in and take a look at some of this data and see, maybe get a better understanding of what we're talking about. Now, this video came to mind after I saw an article that recently came out. And I've considered doing a video like this for quite some time, but I finally had an opportunity to use a real example in real time. Now, this is an article that came out from Engadget about a public database that had 80 million US household information in it. Basically, they were saying that some security researchers found an open database that anyone could get access to that contained full names, addresses, phone numbers, and some financial information. Not credit card numbers or social security numbers, but information about income. Now, this originally occurred from a site called VPN Mentor. And when I saw this, the first thing I saw here was a redacted excerpt of an entry from this database. Now, this article did not specifically state that this database was an Elasticsearch database, but I could tell by just looking at this format that that's exactly what this was. So basically, a couple of researchers were poking around the internet and found this huge database containing information like name, address, gender, income for 80 million American households. And that's pretty substantial. So when I see this, I can tell by the format, this is in a format called Elasticsearch. That's the type of database that is holding this information. And when I see that, that pretty much tells me that these researchers did nothing more than use a website called Shodan to search for databases like this. It's kind of similar to going to Google and putting in a search term and getting a hit, and then you go download or view that hit. There are some differences, obviously. This is a huge database versus just a website, but it is publicly available. It's publicly open information. It shouldn't be, but it is. So when I saw this, I saw up here the word index, and the index of this database was called NAL, which is fairly unique. So the moment I saw this, I simply went to Shodan and I did an Elasticsearch database search. And we're going to go through this a couple of times, but here's the gist. When you go to Shodan, which is a search engine I've talked about in the training already, which looks for databases and devices online, not just websites. When you go there and type in product:"elastic space port:9200, and then the name of any index you're looking for, you will probably get a hit, which I have done right here. So in this situation, I can tell by the news article that the index of this big database that was found online is called NAL. And I can tell by here, by typing in NAL, with the rest of this, I get a hit. And these are the actual databases that are being referenced in this article. Now, to be fair here, as of the recording of this video, both of these databases have been taken offline. Shodan has not updated to reflect that because it just happened. And if you try to go to one of these databases, it will time out because Microsoft took these databases offline once the news story came out. So we can't peer into these two databases, and we can't download these two databases because these have already been taken offline, but we can look at other examples and replicate what many people have likely done to these databases before Microsoft took them offline. So let's kind of recap this a bit. When you see a news article talking about researchers finding an open, exposed database, much of the time you can go replicate that and do that work yourself. Now, I'm not saying that's something you should be doing or something that your policies might let you do. I just want to propose the possibilities here. And we're going to do some in real time to random databases and show you how easy this can actually be done. Again, Shodan is our search engine for these types of databases, and our search is product:"elastic space port:9200, and then whatever you're looking for. Now, we're going to do this 3 different ways: the hard way, the easy way, and the easiest way. I like to start with the hard way first. Let's look at how we do this manually so that we understand what we're looking at here, and then we'll get into the cheat. We'll start using my online tools to automate this process, and at the very end of this video, I will give you a Python script that will allow you to do all of this automatically, and you can literally acquire this type of entire database in a matter of minutes, and it'll be in a nice, clean format. But we'll get to that. We're not there yet. All right, well, let's do a live example. Let's play with this a bit and see what we can find. So we know that these two are offline. That's no good to us. So I'm going to change my search from NAL, which just happened to be that index name, to something a bit easier. Let's look for users. And what I'm doing is I'm searching the word users within any index of an Elasticsearch database online. Basically, I'm looking for databases that have a category or an index called users, because in my experience, when you find an open database that has an index called users, that data is a bunch of personal information which probably should not be exposed, but it is. And everything that we see here, every result that we get, is a publicly available open database. Should it be? Maybe not, but it technically is. Just like you might find websites that Google has indexed that were never meant to be public, but they are, and if you click on them, you can see them. So in other words, we are getting publicly available information here, not private databases. We are not getting locked databases. We are not getting secure databases. We are not ever going to submit any credentials to get access to any of these databases. Everything we see is going to be wide open, publicly available, without any kind of intrusion required or any kind of hack to get the information. All right, let's go ahead and find a target here. And what I'm doing is I'm looking for a couple of things. I'm looking for something that is quite sizable so that we can see a lot of data, and for something that has maybe something of interest. So this one looks pretty good. Here's a US database. It's 349 meg. That's a pretty good size. I like to get things in the gigabyte ranges, but this is probably pretty good. We can start with this. So I can see down here that there is an index or a category called users within this Elasticsearch database. And remember, we're only searching with a specific search term, which we will use the tools for in just a moment, that will only give us Elasticsearch databases which are wide open. So let's go back to that database. Let's go and look at this. Let's see if it's live online. So when we're on Shodan, and by the way, you need to have a registered Shodan account to replicate this search, but you can get the free version of the account. You just have to register and have one ready to go. All right, let's click on this button right here, this little icon, which will open up to make sure that database is open and available, which it is. This tells us that this database is online. We need to make sure of that first. Now, the next thing I want to do is I want to see a listing of the indexes of that database. Now, it shows down here that there's an index called classics, one called products, and one called users. But I want to actually see how big these databases are. So I'm going to do this manually first, but we'll use the search tools in just a moment. Now remember, I clicked this icon right here to just check to see if this server was online, and it is. So I'm going to add /CAT/INDICES ? And in a moment, we'll let the tools do this for us, but let's look at the manual way. Now, when we do that, we get to see the indexes of this database and how big they are. So now I can see that there's an index called users, and it's 14 meg in size. It's not very big, but that's okay. We can use this as a training exercise. So now I want to see the content of that index of this database. And remember, we're doing this the hard way first. We'll do this much easier a second time. So in order to do that, I need to make some changes to our URL. And I'll put all these URLs below, and we'll also use the tools to automate the process soon. All right, so the index is called users. That's what I want. And I'm going to /_search ? Size equals, we'll go 100 records. And now we're actually looking at the data within this open database. Now I'm in Firefox, so I like to look at the raw data, and I like the pretty print option that allows me to really quickly see what I'm looking at. So this database, we just pulled up 100 records, has things like names, email addresses, when the account was created, phone numbers, that's pretty good, I like that, addresses. So basically this is some company's database of all their users, including email addresses and things that are really sensitive. And we might see in a week another news article about this database. Should this data be publicly available in an open database on the internet? Probably not, but it is. And we are doing nothing more than going to a website, and you could replicate this website on your end. And if this database is still up, you would see the exact same thing I'm looking at. It is not a protected database. It does not have a password associated. It is not some kind of secret encrypted data. It is as open as my website, Inteltechniques.com, is open for you to browse around. Now, the 100 here displays 100 records. I could change that to 1,000 and display 1,000 records. And we can tell right up here, the total hits, there's 27,691 users in this database. I could go to 10,000, but 10,000 is the highest we can do, which means even though we are looking at 10,000 users here, we're not even getting half of that database. Now, we could copy and paste and save this into a document and we'd have this data, but it's pretty ugly. It's also a lot of data that we don't want. We could parse it out. We could use various methods that we've talked about in the datasets module about parsing out using ripgrep and sed and all these commands. We could try to clean that up, but that's not necessary either. My point here is just to show you how manually we can see this data. And you see for a lot of these people, you're getting their full names, their email addresses, their home addresses, and their phone numbers. And here, this looks like it's some kind of religious database, the church that they attend. That is extremely sensitive information. It should not be public, but it is. Now, a lot of people, and I'll put myself in this, we collect these databases. We do that to help clients. So basically, I might collect all of the data I find using these techniques and then search my clients within them and let them know where they are exposed. Now, that was the hard way, to take something like a search for the term users and turn that into a list of a partial portion of that online database. Now, I could have changed the word users here to customers, and you will get Elasticsearch databases that have fields called customers, and we get 38 different databases, and some of these are quite large. Here's a 10 gigabyte database. Here's a 3 gigabyte database out of China with customers in it. You can do this all day and never run out of interesting things to look at. Now, let's start over and let's do it the easier way. So I'm going to just close everything out. I'm now on my online search tools. I went to the tools option, IP address, and I'm on the IP address search tool. And there's an option here called Elasticsearch. And this is just a Shodan query. So if I wanted to search for, let's search for leads, L-E-A-D-S. That's leads. It's a common name of a index when a bunch of marketing data is stored, like people's names, address, and shopping history. And if I click on Elasticsearch, it will open up Shodan for you and do the entire proper search, including your search term. You need to be logged into Shodan for this to work with a free account, but basically my search tool under the IP address search tool will let you just put in what you're looking for: leads, users, customers, patients, whatever thing you're trying to research. It will then open up Shodan and it will display all of the Elasticsearch open databases which have leads or whatever you searched as a search term. All right, so now that we've done that, let's find a target. Let's look for something decent here. Let's look for something bigger this time. All right, this one's 40 gig. That's pretty big, and it's out of Canada, so I'm liking this one. All right, so we're going to pick on this. This is some kind of Elasticsearch database, 40 gig in size, that has an index called leads, which is likely there's personal information within this open public database. Now, what I would do is, again, click on the icon to just make a look and see if this is alive, which it is. This tells me this server is online. So I'm going to grab the IP address of this server and copy. I'm going to go back to my search tools, and I'm going to paste it into the Elasticsearch search option for index list. And that will replicate what we did just a minute ago to make sure that that index is still live. And here I can see there's an index called leads. It has many, many records in it, and it's 40 gigabytes in size. So that's a really big database. So let's go look at that. So now I take that same IP address, and on the next line where it says IP address, I paste in the IP address. Now I paste in the index name, which we know is called leads, and this will create that structure that we did a while ago to see that raw data. So we're going to make that prettier with the pretty print option in Firefox. So now I'm looking at this database. I'm looking at 100 records out of, looks like we got 10 million records in this database, which includes people's city, state, first name, last name, user ID, GPS coordinates, contact telephone number, and contact email. This is a pretty good marketing database. This is not quite as big as what we just looked at earlier with 80 million. This one only has 10 million, but that's substantial. And I guess my point here now is when you see a news article about tens of millions of data entry points leaked about people, it really doesn't mean anything. You can go replicate this all day with this technique. You can pull more than 80 million records in your first day and replicate all this data that you're reading about in the news. So now we've used our tool to search for the databases we like. We've used the tool to see the index. We've used the tool and the index name to see the actual data, but we're only looking at the first 100 records out of 10 million. And if I change this to 10,000, we'd only be looking at the first 10,000 records out of 10 million. And even if I added 10 million up here in the URL, it would only give us the first 10,000. So now, how do we get this information? And this is where we're going to rely heavily on Python. Now I have a script, and the script is linked below this video. And this is a small Python script which is going to go download all of your desired data that you want. I did not create this script. The script was created by Jesse. Jesse has posted some other videos about web scraping on in the advanced section of this. And I don't have the skill to write a script like this, but Jesse does. So thanks to him for providing this to the members. Now, if you are on a Mac or a Linux machine, you can just run this script and you're ready to go. If you are on a Windows machine, you do not have Python installed by default. You would have to either install Python or you could use the Buscador Linux operating system mentioned in the second module of this training. that Linux virtual machine, Bouscador, already has the Python software installed in it that would be ready to go. Now I'm on a Mac, so I'm just going to do it on my local Mac machine. If you are on a Windows machine, you either need to install Python or, more easily, just use the Bouscador virtual machine as discussed previously in the training. As you can see, I have my Python script here on my desktop, and this will run from anywhere. I'm putting it on my desktop really just for simplicity and ease of demonstration. If you are running this in Bouscador, then it also might be easiest to save the Python script below this video, save it to your desktop, because wherever you run this script from, that's where the results are going to appear as well. All right, let's go ahead and run a test, and then maybe after we do one, we'll go back and do the first demo that we searched at and see how that would look. I'm going to open my terminal, and the first thing I need to do is switch over to my desktop. When you open a terminal, it's not necessarily going to be open to read data from your desktop, so I'm going to type cd for change directory, and I put in desktop there. So now my terminal is at my desktop. It's ready to launch this script right here. And to launch it, we just need to type in Python. That loads, or that tells your operating system that you're going to launch a Python script using Python. And we're going to type the name of the script, which is elasticsearch.py. Now, when you launch that, it's going to prompt you for the information it needs to do its job. The first thing it says is enter IP address. So we go back to our result. Now remember, this is that big leads collection of 10 million entries of households with some type of marketing lead, and you can see there's a lot of information here. So the first thing we're going to do is grab the IP address. So up here in the URL, we see the IP address. It'll be everything before :9200. That's our port number. This is the IP address. We're going to copy that IP address, go here to our script, and paste. I'm going to hit return. Now it says enter index name. Now remember, this index was called leads. That's the index name. And if we look here at each one of these entries, it tells us right here too. Index is leads. Index is leads. So we know that our index is named leads. We could also look up here in our URL. We see the IP address followed by colon and then the port. And then we have leads up here. So that's the name of the index. We're going to copy the name of that index and paste it into our script. Enter port. Now the default is 9200. In my experience, it's almost always 9200, but this does give you an option if you find an Elasticsearch database that is not that port. So I'm going to type 9200 because I can see that is the port of this database. Now it wants the fields that you wish to obtain. And what that means is, which of these pieces of data on every record do you want to obtain? So the first thing I want is the person's name. So let's copy first name. We see the name of this field is first name, so we're going to copy that and simply paste it into our script. Click return. The next value we want is last name. Right click, copy. We're going to paste that into our script, return. The next value we want, let's go right to, we'll just do phone number. That's below it anyway. So we're going to copy the contact number field and we're going to paste that in. Next, I want the contact email field. We're going to copy that and paste it in. And might as well get the city and state. So let's copy city. All I'm doing is double clicking on each of these field names and pasting them into the script. And if we get city, we might as well get state. Let's copy that. And now we can see that we're going to be grabbing first name, last name, contact number, contact email, city, and state. And we're verbatim copying these from the fields as they're assigned. I don't really need this user ID. That doesn't really mean much to me. These coordinates don't mean much because those are probably just coordinates to like a city center. It's not going to come back to their home, I don't think. And I don't really need anything else. I'm confident. I don't want this stuff right here, whatever this encoding is. That doesn't help me at all. So basically we have this huge database of 10 million entries. There's some good data in here, such as names and emails and telephone numbers, but there's a lot of bad data too. Now, the beauty of this script is that it only pulls out the stuff we want. So now that I have everything, I'm going to hit return. And of course, it's going to prompt me to enter the next value, but I'm done getting values. So basically, once you are done and you submit a blank value, so if I just hit enter again or the return key, it should start collecting my data. Okay, you can see now that the script is running, and it's determined that there are 10,000 pages of results to obtain. Now, a single page might be 1,000 results based on the script, or 1,000 database entries. So what we see here now is that the script is running, and basically it's collecting all of the data we wanted within a text file on our desktop. Now remember, wherever you run this script from, if you have the script installed on your desktop, if you have it installed in your documents folder, in a special folder just for this purpose, wherever you run this script from is where it's going to also save the results. And the result will be titled. In this situation, it'll be titled the IP address, followed by the index name, followed by a number starting with 0. That way, if you are running this script for multiple different Elasticsearch databases, you don't have to worry about overwriting a previous database that you've grabbed. So it's going to title it the IP address that you grabbed, followed by the index. And it will save these as multiple files if it's a large database, such as a 10 million hit database like this is. Now, we can go ahead and take a look at this while it's creating. I'm going to go ahead and open this text file. And I wouldn't recommend doing this while your script is running, but this is just for demonstration, so we don't really care. I'm going to go ahead and open this so we can see what it looks like. This is the text file that it's creating. And you can see it has first name, comma, last name, comma, phone number, comma, email, comma, city, comma, state. It's the exact same order that we told it to grab the information. Now, if we look back over here at the original source, it's not grabbing all of this junk. It's not grabbing a lot of information we don't need, which would just lead to a really, really large file size. It's only grabbing the fields we want and then the order that we told it to grab that. Now, the benefit there is when this is done, we will have this nice, precise, compact file of all of the good stuff from that open database. And by the way, I have the finished copy right here. And if we look at the information on it, it's a 42 gigabyte text file, which is a lot of data. That's 10 million entries of people's names, cities and states, phone numbers, and email addresses. So again, this all fits into that idea of collecting large data sets. So when you do see that news story about researchers that identified a new open database out in the public containing all of this super sensitive information, it's probably nothing more than a public database that you can go find on sites like Shodan. Now, let's replicate this one last time, but let's go ahead and use Buscador, because realistically, we should be using Buscador. It's our safe virtual machine, and maybe we shouldn't be using our host system for this. I was using my Mac environment here, and that works fine. But I should practice what I preach and use the virtual machine that I created for things like this. So I'm going to go ahead and kill this script because I don't need this. That was a Control-C on my keyboard to just kill that. And I'm going to log into Buscador. Now, we have our Python search script. I'm going to copy that. Also, you could have downloaded this while you were in Buscador if you wanted to. And I'm just going to paste this to my desktop in Buscador. So right now I'm in my Buscador virtual machine, stock build, nothing different than what you have. Let's go ahead and replicate this by opening our command prompt. Go to our desktop, type Python, and then the name of our script. And by the way, I hit tab there to fill that out, and let's see what happens. Notice we got an error, and the reason is we are missing a dependency that is part of this Python script that is not installed by default into Python. So if you are using a stock Bouscador build, or maybe even your stock Apple or Linux build, when you try to run this script, it's probably going to tell you that you're missing a dependency called nested underscore lookup. But we can fix that. So we're going to type, just as it says, pip install nested underscore lookup. And that's going to run through getting the information, installing it. You might get a couple of errors here. And if you do get an error that it would not install, you may need to have the sudo command. So let's do that. Let's go ahead and run this again as sudo, which is our super user account, and see if that makes it a bit better for us. Looks like it did. Okay, so we should now be able to go back and type in our command, python elasticsearch.py. All right, that looks better. So now let's go, and let's don't do the same example. Let's use the example that we did at the beginning of the video. So let's just do it from scratch together the right way. We went to my website. We used the search tool. We used the IP address search tool. And down here, we did a search for, I think that one was users. In our Shodan query. And we need to try to find that exact same database. Let's see if we can find that here. I think this is it. 365 meg, that sounds right. Let's see if that database is online. It is. So here's our IP address. Good, we have that. So we're copying the IP address and we're pasting it into our script. The index name, we know it was users. So we can just type that in. Port 9200 default. Now we need to pick out those values. So what I need to do now is take this IP address, go back to the search tools, put in the IP address, the index name of users, and let's take a look at that data. So we're going to go back to our raw data. I like to use the pretty print option. All right, so what do we want to collect here? Let's go to random entry. Maybe I want to collect email. That's a good one to have. So we're going to copy. We'll just type it in email. What else do I want here? I want name. And let's keep it simple. You could put anything you wanted here, but I just want those things. I do see a phone, so let's do it right. Let's do phone, and we'll do address. Once we know what we want and that we're finished, we're going to hit enter again because we leave that blank line to execute the script. And let's see if it starts downloading, which it appears that it is. Now, if I move my command prompt over here, my terminal prompt, I can see it's collecting the data. So let's go ahead and cheat a bit and take a look at that file. And sure enough, it's collecting email address, name, phone number, address. So now we're collecting that entire database, but we're only collecting the pieces of data that we actually want. We're just collecting the good stuff. We're not collecting all of the other junk. We're not collecting the things we don't need. And what that means is our file will be nice and compact. Now this one you see it's only 27 pages because this was a much smaller database. This was only, it was only 300 meg for the entire database. So this wasn't that much data. Let's go ahead and let this one finish completely. We're almost there. We're page 23 of 27. So it's going to let you know how far you are into this activity. All right, we should get a message. It says got all data. Great. And let's go ahead and take a look at the properties of this file. How big is it? It's 4 meg, 4.8 meg versus let's take a look at how big that entire database was. So we're going to grab the IP address and we're going to get the index list. The user's index was 9 meg, so we cut out half of that size by only grabbing the key pieces of data that we desired. So I know that this, again, may seem a little more technical than you might be used to, or it might not be very technical to you at all if this is something you've been doing. In my experience, you're going to find a lot of good stuff publicly on websites like people search sites. That's great. But there's so much good, detailed information hidden within these databases, which you can just find on Shodan. I will warn you, this is quite the rabbit hole to jump into. The first night that I started playing with this, I think I was up all night collecting probably half a terabyte of data. If you do collect data sets as part of your investigations, this is some good stuff in here. If you do any kind of defense work, maybe you have clients that you protect and monitor, this is a good practice to start finding information that could be exposing them that they don't even know about. The sky is the limit with this type of activity because every day, multiple new Elasticsearch databases appear on Shodan. They're wide open. They're public. They're not locked up. And all we have to do is run a fairly simple script in order to start collecting all of that data in order for us to use it as we want. To me, the biggest benefit here is the final product is such a clean text file. It's just that pure data that you want. You could manipulate it more if you wanted to, but I find this to be pretty robust. It's clean, it's minimal, it's the most minimal amount of information we need to grab in order to possess all that data. What I ask is, the next time you see in the news about a researcher that found an open database, especially if they say it's an open Elasticsearch database, try to replicate that. Go over to Shodan and go take a look and see if you can find that database. And if you can, use my search tools to peek into that database. And then if that data is good and you want that content for yourself, then run the script and download all of it for your own personal collection.